Okay, so I wanted to give you a little bit of break from 5.2 and make sure you had time to look back at that problem, understand how we set it up, and solve for a specific variable. So let's go ahead and continue with 5.2, again solving a system of linear equations but with 3 variables. So how would I start number 3 off? I would go ahead and label this as equations 1, 2, and 3. And then you decide which variable looks easiest to eliminate and tell me which one you're going to eliminate. Again, I think z's might look a little bit easier, so I'm just going to say eliminate the z's. So again, you can choose x's or y's. You just decide which one to you looks a little bit easier to eliminate. So if I wanted to eliminate the z's the first time, all I would need to do is take equation 1 and add it to equation 2, which would give me 3x. And then the y's cancel and the z's cancel, and I get 7 plus 2 is 9. So I know that that looks like you're already going to solve for x, but don't deviate from what we said we're going to do. We need to eliminate the variable twice. So eliminate the z's twice. So what else do you need to do to eliminate the z's? Well, since I used 1 and 2, we can use 1 and 3 or 2 and 3. So I'm just going to take 1 and 3 and add those together. So x plus 3x is 4x. Y plus 4y is 5y. Z's cancel, and 7 plus 0 is 7. So now that I still have solved, or I still have eliminated the z's twice, now I can think about solving. I don't have to do substitution or the addition method, because I already know that x is going to be 3 from that, in a sense, fourth equation. So if x is 3, I'll plug in x being 3 into the second equation. So 4 times 3 plus 5y equals 7. So now we'll think about solving for the missing variable. And so y is what we're looking for, and so we're going to end up y being -1. So now that we get y being -1, we'll go back to one of our originals to find z. So we're just going to plug the 3 into the first one, the -1 for y, it's going to turn out to be z being 5. So my order triplet is 3, -1, 5. So sometimes they work out a little bit faster if two variables disappear at the same time. Try number 4. Again, you decide which variable looks easier to eliminate. I'm going to give you the answer, so see if you can get 2, 1/2, and -2. So that would be the answer to 4. So let's go on to number 5. I also want to show you number 5 because it's a little bit different. Again, you're going to look to see which variable you want to eliminate. Well, if you look at the first equation, again, label your equations as 1, 2, and 3, you're going to see that the y is already eliminated. So what you could do is go ahead and take that first equation as our fourth equation, and we're just going to eliminate the y's once. We don't have to do it twice because the y is already eliminated one time. So if we're going to eliminate the y's, we're going to have to multiply the second equation by -2 and add it to equation 3. So we need to do -2 times equation 2 and add it to equation 3. So a little bit of scratch work. We're going to do -2 times equation 2, and that's going to be a -2x, a -2y, a -4z equals -34, and we'll add that to x plus 2y plus z equals 16. Adding that together, we get a -x, the y's cancel, we get a -3z, and we get a -34 plus 16, which would give me -18. So again, my fifth equation would be -x minus 3z equals -18. Then at that point, we can see that probably the addition method would work well here by just taking equation 4 and 5 and adding them together. So when I do so, the x's cancel. Z minus 3z is -2z, and 8 minus 18 is -10. So we're going to get z equaling 5. Don't go back to one of the originals yet. Stick with one of these so you can find the missing the variable, which would be x. So if I take the first equation, I have x plus 5 equals 8. So x would equal 3. Then if x equaled 3 and z equaled 5, now you can go back to one of your originals to find y. But you can't use the first equation since y is missing. So if you plug it into, say, the second equation, we get a 3 plus, we're looking for y, plus 2 times 5 equals 17. So 2 times 5 is 10, plus 3 is 13, equals 17. So y would equal 4. So my answer would be 3, 4, and z. All right, so there's some different things that can happen with these problems. Number 6. So again, we can think about which variable looks easier to eliminate. And I'm going to go and just give you the answer to number 6. Work it out and see if you get 1, 4, and -3. So make sure you can do that one. On number 7, I'm also going to give you that answer, and the answer to number 7 would be a no solution. So again, see if you can work that one out by getting a no solution. And now let's do number 8 together. So on number 8, as you can see, we're already missing the y, so you might want to choose to eliminate the y just once. So we could say eliminate y's once. Now if you do that, you have to use equation 1 and equation 3 because those are the only ones that have a y in it. So we would take the second equation as my fourth equation, and I would go ahead and eliminate the y's once by using equation 1 and 3. So we would have to multiply the first equation by -3 and add it to the third equation. So again, some scratch paper, -3 times the first and add it to the third. So -3 times 2 is -6x, -3 times y is -3y, -3 times -3 is +9z, and -3 times 4 is -12. And we're going to add that to -2x plus 3y minus 13z equals -8. So that becomes a -8x, the y's cancel, -4z equals a -20. If you see there's a number in common and would like to divide everything by, say, 4, that would be great, or you can just leave it as is. I'm going to divide everything by a 4. So if I divide this by 4, this by 4, and that by 4, I get a -2x minus z equals -5. Again, that is not a necessary step, but you can if you want to make your number smaller. So now we have two variables and two equations, so let's go ahead and figure out which variable looks easier to eliminate, or you could do the addition method. I think the z's look nicely to be able to multiply by 2 to eliminate them. So the first equation stays the same. And the second equation multiplied by 2, I get a -4x, a -2z equals a -10. So my x's cancel, my y's cancel, and my 10's cancel. So I get 0 equaling 0. So when I get 0 equaling 0, that means I have infinitely many solutions. And in chapter 6, we're going to learn how to write that as a complete solution. So just to give you a heads up of what happened is my three planes intersected at a line, and that's where I got infinitely many solutions. So if you need more help on these, I'd be more than happy to do an individual Zoom session with you. But you've got to figure out which variable looks easier to eliminate them twice. All right, so we have two word problems. We're just going to set them up. I'm going to give you the answers, and hopefully you're going to solve them on your own and make sure you get to that right answer. All right, so at a production of Streetcar Named Desire, we have 400 tickets were sold. The ticket prices were 8, 10, and 12, and the total income for the ticket sales was $3,700. How many tickets of each type were sold if the combined number of $8 and $10 tickets gets sold? So when I would teach this in class, I would say, okay, that makes no sense to me. So what we have to do is we have to be very picky and pick out the pieces that matter. So the first thing is you always want to look at what is your variable going to represent. And this is how many tickets. So we know that we have three different prices, 8, 10, and 12. So we're going to have three different variables. So X is going to be the number of tickets sold at $8 a piece. Okay. Y is going to be at $10 a piece. And Z is going to be the number of tickets sold at $12 a piece. Now remember, these are representing the number of tickets. We're not talking about a cost, we're talking about the number of tickets each. So looking at the very first sentence, we know that there were 400 tickets sold. So if we have 400 tickets sold, then that means X plus Y plus Z should equal 400. We like that equation, so we're going to go ahead and write that into my system because I can't make that any nicer. Looks pretty good. All right, so there's my first equation. Now, the ticket prices were 8, 10, and 12, and they had a total income of $3,700. So my money all goes together. So 8 times the number of X tickets sold, plus 10 times the number of Y tickets sold, plus 12 times the Z tickets sold should be set 3,700. Now again, if you want to make your life a little bit easier, you could divide everything by 2 to make your numbers a little bit smaller. Again, that is not a necessary step, but it sometimes does help make it a little bit nice. 5y plus 6z equals 1850. So the last equation is always one of the harder ones. Normally you'll have an x plus y plus z equaling a number, and then you're going to have a cost equation. But we have to now somehow translate this next sentence. If the combined number of $8 and $10 tickets sold was 7 times the number of $12 tickets sold. So that's what I'm trying to translate. How do we combine 8 and 10, X and Y? So X plus Y, that means combined, if that's what they were sold, was is equal 7 times the number of $12 tickets. Which one represented the $12 tickets? That was Z. So that's it, just X plus Y equals 7Z. Now I don't want to write that one over here because if you think about how we normally do it, we want all the variables on the same side. So I need to subtract the 7Z. So X plus Y minus 7Z should equal 0. And now you're ready to solve your system. Which variable looks easier to eliminate? I would probably say the X's or the Y's, not the Z's this time. So if you solve it, you should have 200 tickets sold at $8. You should have $150 ticket or 150 tickets sold at $10, and then you should have 50 tickets sold at $12. So again, try and solve these. Make sure you're getting the right answers. And if you have questions about how to solve them, let me help you. All right, so the last one is we're going to set up number 10. A person has invested $6,700 for 1 year, part at 8, 10, and 12. The total annual interest was $716. That's that next sentence we have to learn how to translate. But let's look at what the question asks. The question says find the amount invested at each rate. So X is going to be the amount invested at, say, 8%. Y is going to be the amount invested at 10%. And Z is going to be the amount invested at 12%. All right. So what's the first equation? Well, we know we invested 6,700. So X plus Y plus Z should equal the 6,700. X plus Y plus Z should equal 6,700. I like that equation. Can't make it any easier or nicer because all of these already have a coefficient of 1. All right, so what about the second equation? Well, let's talk about our percents. Our percents give us our interest, and the interest we earned was $716. So the interest at 8%, so 0.08 times X, plus 0.10 times Y, plus 0.12 times Z has to equal your interest, which is $716. Now normally we don't work with decimals, so we would multiply everything by 100 to move our decimal twice to the right. So 8x plus 10y plus 12z equals 71600. Again, if you do not like larger numbers or want to work with a little bit smaller, I would divide all of these by 2. That's not a necessary step, but it does make your number smaller. So 4x plus 5y plus 6z equals 35800. So then that last sentence is the one we have to translate. The amount of money invested at 12% was 300 more than the amount invested at 8 and 10 combined. So which variable represents the amount of money invested at 12? That was your Z. So Z, and then it says the amount of invested at 12% was is your equal sign, 300 more than the amount invested at 8 and 10 combined. So combine 8 and 10, and then do 300 more than that. So x plus y plus 300. We like the variables to be on the same side, so I'm going to subtract the x and subtract the y. So my last equation would be negative x minus y plus z equals 300. And then again, you can solve this out, and when you do solve it, you should get 1,200 invested at 8%. You should get 2,000 invested at 10%, and then you would have gotten 3,500 invested at 12%. We can certainly do more of these in our class time, or if you want an individual Zoom session, we can do that as well. But definitely try those out and make sure that you can solve them correctly.